Hello, welcome to Maps of Math. Today I'm going to do a quick video just talking about two different classes of rings. So we're going to talk about these operator-like versus these function-like rings. So one class are going to be these non-commutative or operator-like rings. In this case, the elements of the ring, which are going to be elements of a home set, they're going to act like transformations of space. And so our example here is going to be linear transformations Rn to Rn, which clearly transform Rn, map all of Rn into itself. Then there's going to be a very different class of rings in terms of what they feel like, how they're motivated, and these are going to be the commutative or function-like rings. So here, elements are going to behave like observables in the space, and so a simple example will be continuous functions from 0, 1 into R. Let's look at each of these. So for the operator like, we're going to have one object being transformed. So let's just stick with our Rn example. And so we can look at the linear transformations Rn to Rn. So if we look at L and T as two different linear transformations, well, we can go Rn to Rn by a L, Rn to Rn by a T. So you put them together, we can compose them. And this composition is actual function composition. So here the ring multiplication is a actual composition of the functions. So if I actually evaluate this on a given v, it's going to be L on v and then T on L on v. And in particular, in general, then L composed with T is not going to be the same as T composed with L. This is non-commutative. Some of the linear transformations that'll hold, but most it will not. What about the other case? So in our other case, we're going to have function-like rings, which there often are function rings, but there are others that are not function rings, but they're like this. So let's take our continuous functions from 0, 1 into R. We think of these as observables. So for each x in this interval, we think of it giving an observation. In this case, it's just a real number. You could make this C0, 1 into whatever space, or you could make it Cx into some other value. So this is where it's gonna, this is a much more geometric feel where these are like sections of some bundle. And then we could think of, say, when we think of then a function f that's inside of here, well, this is mf or multiplication by f, so you can think of the transformation. It'll take a g and do f composition g. This composition is now pointwise. So it's not, so if I actually evaluate, so as I say, this is pointwise multiplication, not actual functional composition like the last one was. So here, if I want to evaluate on some x, that's actually defined to be f of x times g of x. So this is real number times real number, not this plugged into f. And similarly, if I can look at adding f as a transformation on these functions. So g to f plus g, same idea. It's pointwise addition. So it's useful anytime you're encountering rings, you can look and say, hey, which one is this like? Is this operator-like ring that's going to be non-commutative and transform some space, or is this a function-like ring that's almost always going to be commutative and it's going to combine observations pointwise through some sort of addition or multiplication? All right, that was it for this video. Just wanted to make that point. Hope you enjoyed it. Until next time, be well.